Alright, so here we are with 10.1 and we're organizing and displaying data. So, our objectives here are to organize data in tables and graphs and choose a table or a graph to display the data. Super. You'll also hear me say data, and both are fine, so it doesn't really matter. Alright, so the first thing we're going to look at, and you've probably seen these, are bar graphs. And your bar graphs officially display data with vertical or horizontal bars. So here's a horizontal one down here. Bar graphs are a good way to display data that can be organized into categories. So here you are with the categories of ingredient. And then, of course, using a bar graph, you can quickly compare the categories because you can see which one's taller, which one's shorter, all that good stuff. So, when we read and interpret a graph, and this is what your assignment will also be like, we're going to use the graph to answer each of the questions. So, in this first one here, we're looking at this graph that has casserole orders, and apparently this is the type of casserole. It's just something that usually has noodles that you bake in the oven. And then over here we've got our orders, so how many people ordered that casserole. So, must be at a restaurant or something. Alright, so the first one here, which casserole was ordered the most? Hey, well, it's probably the one that is the tallest graph here. This one here doesn't necessarily label that this is 60 up here, but it is going up or over the furthest. So which casserole was ordered the most? We're going to say lasagna or lasagna. About how many total orders were placed? Ooh, so this is an interesting one because with bar graphs, it's not necessarily apparent. How many of each piece are there. So for instance, here I'm seeing it's between 20 and what would be 30, and it's a little bit closer to 30, so I'm going to say maybe about 27. And it does say about, so you never know. This one here is very close to 20, so how about we just say 19? Okay. The orange one here is just about over the 30 mark, so we'll say 32, sure. And then the last one here is a bit of a ways over 40, so how about like 44? Okay. So you add them all together, 44, 32, 19, 27-ish, and 60. And we get 182 orders. Now, of course, you could have gotten something within the range of maybe 170 to 195 or something. The idea is that it is about how many, and of course it is depending on how you interpret the graph, since it's not exactly listed. Alright, the next one says about how many more tuna noodle casseroles were ordered than King Ranch casseroles. Let's see, tuna noodle was about 44, and King Ranch was 32-ish, so we'll do 44 minus 32, and we'll get about 12. Alright. And what percent of the total orders were for baked ziti? So baked ziti is 19, and we knew that the total was 182-ish. And so, let's see, 19 divided by 182, whoops, that's a 2, is 0.1044, and so technically that's 10.44%. And since we're estimating, it may as well be about 10, but 10%. So we're interpreting the bar graphs again, not necessarily an exact science based on the data given, but that's perfectly fine. Alright, then we have a double bar graph, and so usually there happens to be two things that are happening within a time frame, and so they get to group them together. So officially it's used to compare two data sets and usually has a key to distinguish between the two colors of what's going on. So it's not its own category for each column here. It's within each column there's red for football and orange for basketball. So basically here we're talking about average attendance per game. Okay, so this is, and then notice they put it in thousands so that these numbers are a little easier to interpret. That's nice. So this really means 5,000 and 10,000 attendees. And it's for apparently state college football and basketball attendance. Alright, so we're going to use this next graph to answer each question. Super. SUVX and SUVY. Okay, so we're comparing SUVs, meaning sport utility vehicle cars, and we're comparing these two XY. We're not naming them, so just SUVX and car Y there. On their price, cargo, comfort, safety, mileage, all that good stuff. So, which feature received the same satisfaction rating for each SUV? So we're trying to find out which bars are very close together. So that's going to be cargo. Oh, I already answered it. And then this one's already this answer, so let's just make sure it's right. So which SUV received a better rating for mileage? So here's mileage, and you would assume more is better because I assume this is percentage. Doesn't actually say, so that's weird. Anyway, so definitely this blue one here, which is Y, is taller, and so I would assume at 50% satisfaction versus 30-some satisfaction is better. So SUVY. All right, then we have line graphs. So line graphs display data using line segments, and so line graphs are kind of like a dot-to-dot. They're a good way to display data that changes over a period of time. So you can kind of see its increase or its decrease and compare that. So this one here is temperature of a day starting at midnight to 8 p.m. And so you're just seeing how with the sun and everything, the temperature rises and then falls. Alright, so now we're going to interpret one. So we're going to use the graph to answer each question. Super. At what time was the humidity, because this is looking at percent of humidity, the lowest? And so that would mean the shortest on the graph here. And so I'd say right here at 4 a.m. would be the lowest humidity. And then during which 4-hour time period did the humidity increase the most? Okay. So I'm guessing since this is the lowest point and this is the tallest point, that is in fact going to be the largest 4-hour period. Oh, never mind. Huh. Each of these is a 4-hour period. So we're just looking for which one has the largest slope. And they are looking for increase, so we are going to want to do it here where they're increasing, and the tallest one, you know, it's hard to tell, so if you wanted to say 8 to 12, 8 a.m. to noon, or noon to 4, I think those would work. I can't quite tell which one is taller. I feel like noon to 4, but hey. All right, so now we have a double line graph, and so this is going to be two pieces of data throughout the time period, or in this case, a year, January, February, March, April. And we're talking about airfare between two cities. So they're used to compare how two related data sets change over time. So a double line graph has a key, again, just like the previous one, with histograms between the two sets of data. So we've got airline B, airline A, and their prices. So it looks like throughout most of the year, airline A has an increased price, but maybe that's because they allow baggage or something. All right, so here we are going to try to understand one. In which month did Station A charge more than Station B? So Station A is the red one, so when is the red above the blue? And it looks like it's in January, February, March, April, May. So apparently May. And then during which months did the station charge the same for gasoline? So we're trying to find where both of them have a dot on the same piece, and so that would be there. And so that would be April. And maybe I can erase that so you can see, but definitely right here is where a blue and a red dot are meeting. All right, then we have circle graphs, which talk a lot about percentages. So Circle graph shows parts of a whole. The entire circle represents 100% of the data, and each sector represents a certain percent of that total. So you can definitely see here, this is like a fourth of the circle, this is another fourth of the circle, but this is more than a fourth of the circle. So circle graphs are good for comparing each category of data to the whole set. So you can kind of see what's taking up space within the data. So the sections of a circle graph are called sectors. And we do talk about that actually in geometry a lot. We talk about finding the area of sectors. So, all right, so here's this next one here. Just a side note, they should add to 100%, right? Otherwise you're missing some sort of category or a certain represented data point. So, which ingredients are present in equal amounts? Okay. Well, based on the fact that this one says 50, this one's 25, and these are both 12.5, looks like lemon and pineapple juice are both the same at 25%. Lemon sorbet and pineapple juice. Oh man, I love me some punch. Okay. Alright, and then the last one here. We are talking about which one could best be displayed by what we have so far. So, using the given data to make a graph, explain why you chose that type of graph. So we're not necessarily going to make them, but if we were, what would we use? So this first one here has flowers in an arrangement. And there's, let's see, flowers of these 4 and the number of them here. Let's see, I'd say a bar graph could work with this. Yeah. They don't necessarily make up a whole. I mean, if you're talking about the entire arrangement, I guess you could do a circle graph. So I'm going to say bar or circle graph, but in case you're wondering, the answer key doesn't necessarily say circle graph. But if we're talking about an arrangement in total versus in a store, anyway, circle graph works. The next one here, use given data to make a graph. We have degrees held by a facility. Oh, by faculty. Hi. The degrees are PhD, master's degree, and bachelor's degree. And then we have the number of people that have them. And so this is the entire faculty. And so as long as you know the entire faculty, I would definitely say a circle graph. However, you could really make any of them work except maybe a line graph. That would be weird. And then county farms. Okay, so in 1980, there were 265 farms in this county, et cetera, et cetera. And a lot of times with dates, it's definitely easier if you do something like a line graph, especially because it'll show it over time. But you could do a bar graph, potentially. So, that's the idea. And again, most of what we're doing here, this is statistics in Chapter 10, it's up to interpretation. So if you interpret it differently, as long as you can explain to me what that interpretation is, then we should be able to move forward. So, 10.1, organizing and displaying data notes.